I'm just bringing up something I'm working on. It's still a work in process. This is a bot I'm putting together for the FloorBot challenge. Hopefully have it ready by next month. We'll see.
That's a challenge.
Yeah, yeah. So the history of this little guy, I call him Lambo because it's a Lamborghini. And you know, my theme, all robots have evil names. So unless you're a Packer fan, Lambo's kind of an evil name. So anyway, yeah. So the challenge of this guy is Mikey picked this up for me for $5 at Goodwill a year or two ago. And the challenge is to take something that costs $5 used, you know, left over, the remote was gone, all that kind of stuff. And actually, you know, make a functional robot out of it. That's kind of my challenge with this one. Make it work. And that's the inside. You know, it's the RC cars. A lot of these cheap RC cars have the same receiver chip basically, and there's only 4 pins you need to drive and connect to control the bot. You have right, left, front, back pins on the receiver chip. So it's really easy to take one of these El Cheapo RC vehicles and make an autonomous bot out of it and control it from
What
Arduino.
is the FloorBot challenge?
Sorry?
What is the FloorBot challenge?
You should know. You know. So if, yeah, for people that are new, the FloorBot challenge is basically, it's like a bigger version of TableBot. TableBot, you go from one end of the table to the other, don't fall off, turn around, go back to the first edge where you started. FloorBot, you basically start over there, you go across the room and, you know, detect the wall, turn around, come back to where you started. And then there's higher levels of it where you can like detect objects, retrieve objects, etc. But the basic idea is just to, you know, go back and forth without, you know, and control your movement and stuff, and detect your direction and things like that. So that's what I'm working on, and it's got a little SparkFun red board on here. It's basically an Arduino Uno, and so obviously I'll be running ROS. Arduino? No, but I won't be running ROS. And anyway, yeah, maybe so. Anyway, so that's really it. You know, having a little fun with it. You know, a little $5 used RC car, make a FloorBot, yada yada. So
Next month is the HPRC challenge.
Next month is the level 3 challenge. Yes, indeed, exactly. I'm going to put a couple sensors on here, looking out through the windshield, and that'll be pretty much it. Any questions, or pretty straightforward? Probably wondering how to run ROS on Arduino. Huh? I can't demo it right now. I don't have. It's not finished. Close. I just need the sensors, and then we'll be done. Thanks.
All right.
So you drive the robot around. Bear with me. Things are going a little too well. And you see now, okay, he's clearing out the rest of this map. Okay, this is ROS, all right? And by the way, we're having a great time at the HPRC SIG Special Interest Group. We've merged with the SV ROS, Silicon Valley ROS group, and we do ROS on the penultimate Wednesday at the Tech Shop in Redwood City. So we're having a lot of fun there. So here, oh, I'm going to spin him around one time. This is the teleop twist. I'm actually controlling the keyboard. You control it with a joystick too. Let me just fill in this map a bit. Okay, bear with me. I'm going to my cheat sheet now. And I want to copy the map and save the map. Be sure and save your map before you kill the Gmapping program. Otherwise you'll lose your map, okay? So I'm changing to the proper subdirectory, and here's the command to save the map, and I'm saving the map. Boom, the map is now saved. So now Ralph Knock, ladies and gentlemen, I pronounced the G out of respect, wrote some marvelous launch files for the BotVac package. We're talking about and building the BotVac, the MaxBot, may rest in peace, the MaxBot out of the BotVac with Dr. Alan Fetterman there at the HPRC SIG, which is the SV ROS. So here's a marvelous launch file that loads in the navigation stack. The navigation stack in ROS stands for Robot Operating System, loads in what's called Move Base and AMCL. Move Base is basically your path planning. You'll see a little green line. That's Move Base. And the local cost map that you see light up all around the obstacles, that's the AMCL, Adaptive Monte Carlo Localization. And so here we go back to the RViz, the GUI, ROS visualizer, And that's what we drew this marvelous map with, okay? I'm not proud. And we'll kill G-mapping, grid mapping. Again, be sure and save your map before you kill it, otherwise the map is gone. Now I'm going to paste in the navigation stack launch file, Ralph, thank you, that loads in the map that we just saved, okay? And here, around the borders, you'll see the global cost maps in blue. And around the robot here in a bit, where's my robot? Any day now. Oh, there's my robot. When you run G-mapping and you load in the map, it assumes that the robot is located where you started. It's not. I left him out here. So he started over there in the corner here, and so that's where he thinks he is. So let me do one thing here, and that's I'm going to set the robot's pose, okay? So I need to tell it that the robot's over here-ish. You see what I did there? I clicked on 2D pose estimate, and I said, ooh, the robot's here. Okay, and just for fun, let's navigate over that corner and get him a little better localized, okay? So I'm clicking on the 2D nav goal, and I'm point, press, and dragging. Here I can set the pose of the robot, or which way it's pointed. So I mouse up. You see the green line there? That's the move-based path planning. And with any luck, the robot will start moving in that direction. Anyways, right now, this is RViz. It's really a great thing. Here we got the whirling dervish, ladies and gentlemen. The robot's attempting to figure out where the heck he is. Hopefully he can get enough of this podium to figure it out. By the way, this is your robot, Bill. I meant to do this before we started, but inside the dirt bin of this bot deck, this vacuum cleaning robot, is a Raspberry Pi. And it's using this SV-ROS. What do you do, David? He's using this SV-ROS package, to make these maps and navigate. As you see, I'm just clicking here and there, and the robot's navigating here and there. So here you see some of the local cost maps lighting up as it sees the wall. It should see that corner soon. Boom, there it comes. And again, this is cool stuff. Thank you, thank you.
Yeah.
All right. Working around that, folks. And so here, it's really cool because see, you can zoom in on this, and you can look at it this way, and you see the little LiDAR scans, and you go in there and stuff like that. And so, questions? Come on, somebody's got a question. Okay, again, we're teaching this stuff in the. Oh shoot.
You got the bumper code working yet?
Oh, yes, we're working on the bumper code, right? We're having some fun at the everything. What's exciting here is all of this mapping and navigation is done with just stupid me. It's done with just the LiDAR. If you're wondering what I just did, I was trying to set a goal, and I just clicked on pose and told him the robot it was way over there. Anyways, so we're doing this stuff at the SV-ROS meeting. If you're interested in learning how to navigate with ROS, that's the place to be. Yes.
So I see it has the footsteps of a person that entered the room.
Yeah.
I'm wondering, can you set the decay time?
Yeah.
How fast?
Yeah, there's parameters in there. You can
You
set
saw something
things.
just decay now.
Yeah. Yeah. And so it'll path plan around obstacles, like David there. Hello, Shiloh.
Hi, Shiloh.
So nice to see you. Shiloh Curtis, ladies and gentlemen, from Boston, in Boston, Massachusetts, MIT. I think they're in Boston, Massachusetts. Okay, so that's it. I'm done.
Viking, Shiloh.
Thank you. Thank you.
Okay, I thought it was impressive.
Thank you. Hey, Nathan thinks it's impressive. That's all I was looking for.
We had
Bring it up front so we don't
we
have
had
to
some conversation, and I don't know if the person who brought it up is here, but there was a question about, should I buy a pad bot? So I happen to have a dead pad bot, so they don't have to buy one. I'm not sure, is the person who sent that here? Pad bot, anybody remember the conversation?
Right.
Anyone see the conversation?
Yes.
Or am I hallucinating? I could be hallucinating. Anyway, this is a pad bot for anybody who wants to look at it. And if somebody wants to take it home with them, that's fine. I'm cleaning out my garage.
So, ladies and gentlemen, I have Magni here, and it's running our newly updated Follow Me algorithm. It's available on GitHub. You have a fiducial. The robot follows the fiducial. It'll stop, turn around, and look for it. If it loses the fiducial, otherwise it just sort of follows the fiducial wherever it goes. I also thought it'd be nice because we had arriving from China a box, and I thought it might be fun if we just open that box, because this is how things arrive from China these days. Let's see what we've got inside it. Well, we'll see, right? I mean, you know, like, we'll see, because in here, so another one. It's got the sensor package in here, and we're ready to go.
$5 American right now.
There you go. Thank you. So yeah, so that's Magni. The code for the Follow Me, demo.
We show that to you.
Oh, sure. The code for the Follow Me demo is.
Is that one that came by boat, David?
No, this is one that came by air. We have 7 more that are coming by boat. Yep.
I'm sorry, the flash wasn't.
Oh, sorry. Technology.
Likely to get your work out.
So yeah.
David, I'm sorry, but I don't have enough battery power to do a flash. But I actually managed to get a good shot. Thanks.
So this is one of the 2 that came by air. We have another 7 that are coming by boat, and hopefully many more. We'll see, you know.
Why do you need so many?
What's that?
What do you do with so many?
Because people want them, right? So yeah, people want them. There are lots of people that want the robot, and I have an aspiration. Maybe you guys can help me with this aspiration, which is that I want to go for the Guinness Book of World Records for the world's longest robotic Congo line. There are a number of world records on Congo lines, longest Congo line, the longest distance covered in a Congo line. As far as I can see, there is no world record yet for the world's longest robotic Congo line, and I think that we should try to set it.
So you're shooting for 2?
Well, we did 2 actually. 2's already been done. I did 2 in Roscon on the weekend. But with me and a LiDAR bot, funny that is, but yes. So the software is there on the GitHub, github.com/ubiquityrobotics. You can download it, try it. It all runs under ROS, so if you've got a ROS-based robot, you can just play with this right off the bat. Obviously, download it, try it, contribute back, fix some of the bugs that still exist. Tell us about new bugs that we didn't know existed, and you know, generally have fun, of course. All right? Thanks very much.